The Indian Association of Structural Engineers, also known as IAStructE, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IAStructE is registered under the Society's Registration Act 21 of 1860. IAStructE is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IAStructE has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar as its president. IAStructE is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IAStructE has collaboration with various international professional like-minded associations and institutions. IAStructe's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IAStructE endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IAStructE is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IAStructe's activities are widely appreciated and known for quality technical contents. IAStructE is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines and a monthly newsletter. IAStructe's publications are becoming popular with time. IAStructE has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IAStructE started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IAStructE is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IAStructE has its student chapters in several leading engineering institutions as well. Membership of IAStructE is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IAStructE is available on its website www.iastructe.co.in.
Yeah, Dhawan sir, please start.
Okay. Hello, dear friends. Welcome to the webinar. We organize such webinars every month. Uh, so today the topic of the webinar is earthquake resistant design of foundations. Uh, the speaker of today is Dr. Srish Kumar Sharma. He is former commissioner and secretary PWD Andamans and chief engineer CPWD. About the speaker, Dr. Srish Kumar Sharma obtained his PhD in Geotechnical Engineering from IIT Chennai. He worked in CPWD for over 35 years and was associated with planning, design, and construction of various projects in building roads and bridges in different parts of the country. Uh, uh, about the topic, the webinar shall deal with body and surface weight, magnitude and intensity of earthquakes, soil dynamics, which shall include dynamic testing and liquefaction and Codal provenance. Now, I request Dr. Srish Sharma to proceed. Dr. Srish Sharma, please proceed.
Good evening, sir. Am I audible?
Yes.
Good evening to all the dear participants. It's my honor to make a presentation on this important topic of earthquake-resistant design of foundations. So, is my screen visible, sir? Are you able to see my screen, sir? Kindly
Yeah.
confirm.
Yes, sir. Visible.
Okay.
Please make it full screen, sir.
Make it full screen.
Okay. Let me set it. Is the screen visible, sir?
Make it full screen.
Yes, sir. Visible है लेकिन उसको आप उसमें कर दिए PPT mode में. You have to click on the bottom at the means just like a cylindrical shape.
Is
Yes,
it
sir.
okay?
Yes, sir. Yes.
So today I am making a presentation on a very important topic of earthquake-resistant design of foundations. For the information of dear participants, may I submit that there is a dedicated course on the same subject being conducted by Professor B.K. Maheshwari of IIT Roorkee. I was myself a beneficiary of that course. 18 people qualified in that course. I am one of those 18 people. I am still a learner, like our coordinator, respected Dr. S.K. Dhawanji, who got his doctorate at the age of 77. I am still a student. I am a learner, and PTEL courses I am still undergoing. I am entering now for 12th certification course. So this was one of the certificates which I earned from NPTEL, which is an organization funded by Government of India. So this single lecture obviously cannot replace those 40 lectures by that IIT Roorkee professor. So I will be discussing some basic issues relating to the subject matter. Here in the inset, we see the photograph of Japan on 1st of January this year when we had an earthquake of magnitude 7.6 and it caused casualty of the order of 160 persons there. Here in the inset, we see disruption of the pavement, then we see damage to the roadside fencing, and there is instability caused to the ground also. So this is one picture which is an eye-opener. In a country like Japan, which has all the facilities, later research is going on, they have this type of problem. I will proceed further. Here, let us have a look at the Mother Earth. Outside we have crust, then we have mantle. People have classified this mantle also into upper mantle and lower mantle. Then we have outer core and inner core. Outside at the crust, we have various temperatures, 30 degrees, 20 degrees, 0, sub-zero also. As you move toward the interior, toward the center, temperature rises up to around 5,000 degree Fahrenheit. So here you have solid mass near the center. Outer core has molten material. This inner core has nickel, iron, etc. And specific gravity of the materials is of the order of 13.5 to 14. Whereas at the ground surface, specific gravity of the material is of the order of 2.6, 2.7, etc. So as you move towards the center, specific gravity rises. Average specific gravity of the material across the radius of this earth is of the order of 5.5. And there are temperature differentials also. So there are thermal gradients across the radius. And below this crust, you have rocks and soils, etc. And these rocks are fractured. At macro level also, there are 7 major plates. Our area falls in Indo-Australian major. And there are 14 minor level plates which have been identified by geologists. So there are thermal gradients across the radius. Earth is moving about its own center, then it is moving in the solar system also. And there are cracks and fissures within the body of the Earth. So because of such actions, there is lava eruption from time to time in various parts of the world. In India also, there is one barren island located in Andaman and Nicobar Islands, where we have this volcanic activity every day. That particular island is burning every day. There is no habitation there. In Japan, there are lava eruption at number of places, and this is one of the causes of earthquake. Secondly, there are so many major and minor plates which are loaded with stresses. So they have stored strain energy. These plates keep on striking from time to time. Now, we are in a very probabilistic domain. We do not know which plates will strike where, what will be the magnitude of that earthquake, which will be generated out of some collisions. Some collisions are divergent in nature, some are colliding, moving towards each other, plates are moving apart also. So there are so much phenomena which is happening within the body of the earth. And these are not in our control at all. Below this lithosphere, top one, say around 100 kilometers or so, material is relatively fluid. And in the outer core, it is all liquid material. Specific gravity is quite high. So in this type of unstable floating system at macro level, we can never say when any earthquake will take place, where and what will be the magnitude of that earthquake. So the whole thing is very probabilistic. We are placed in a situation where we are neither sure about the magnitude of the forces, we are not sure about the resistance of the soil also. Of course, a lot of research is going on. I will show some of the slides relating to that. Let us have a look at the basic terminology. Here we see the ground surface, horizontal one. Then this is a fault line. Fault line is a weak plane. And most of the earthquakes happen with focus lying along this fault line. So the point where this release of energy takes place is known as focus. We call it hypocenter also. The point vertically above the ground known as epicenter. And the distance from this epicenter to focus is known as epicentral depth. So when we talk about magnitude of an earthquake, it relates to the extent of strain energy released here at the focus. When we talk about intensity, it is what we feel at various places on the earth. For example, near the epicenter, intensity will be the maximum. As you move away from the epicenter, this intensity comes down. I have seen that many times, many of our enlightened friends holding doctorate also, they mix up intensity with magnitude. Both are quite different. Magnitude is here at the focus. Intensity is here at various places of the earth. For example, on New Year, this year, Japan faced the earthquake. In Japan, they felt the intensity, whereas in our country, we did not feel anything. So there is a lot of difference between magnitude and intensity, which we must know. Now, I move to this wave propagation. In fact, a lot of work has been done on wave mechanics. Mr. Kolsky has written a full-fledged dedicated book on wave propagation. Here, in the insert, we see a photograph of layman toward the left who discovered E wave. We call it compressional wave also. Towards the right, we see the photograph of discoverer of S waves. This P waves we call as primary wave also, compression wave also, and S waves we call as shear waves also, secondary waves also. So the combined effect of body waves and shear waves, which we see at site at various locations, our foundation superstructure reacts to the action of these body waves and surface waves. Here in the left, we see the propagation body wave, and see in this picture about the effect on our structures, foundation, and it could cause instability of the soil also. In the right, we see a photograph which shows the ground movement due to propagation of surface waves. This photograph was taken 5 years back in America, where an earthquake of magnitude 7.1 struck. This type of dislocation, this type of ground movement can cause lot of damage to the foundation, to the structure. And we do not know the direction in which this earthquake wave will strike, what will be the magnitude, whether it is predominantly in horizontal direction. Generally, it is in horizontal direction, but in vertical directions, we have come across cases. For example, in 1995, in Kobe, they suffered many bridges failed because of motion predominantly in the vertical direction. Here we see the physical action involved in case of P wave propagation. You see, in the bottom, we see the physical picture. The spring action is analogous to behavior of any element of soil below the ground surface. This is the direction of propagation of the wave. And just see how an element of soil gets compressed. This P wave consumes around 7% of the total energy released in an earthquake. And this is a body wave. This body waves propagate down below. Focus is below the ground. It may be located at 50 kilometers, 100 kilometers. Now we see the physical action involved in case of S wave. In the right side, we see the physical picture, physical analogy. And just see how particle motion can take place with reference to the direction of propagation of the wave. This S wave consumes around 25% of the energy involved. So taken together, the and S wave together consume around 1/3 of the total energy in an earthquake. Remaining 2/3 of the energy is consumed by propagation of surface waves. There are two types of the surface waves which are of interest to us, namely love waves and last one is Rayleigh wave. Rayleigh wave is the most disastrous. You know, the propagation of those waves is similar to what we have when we throw a piece of stone in a pond. There is elliptical motion of the particle. Elliptical motion of the particle. Likewise, that Rayleigh wave is very, very damaging, the most damaging, that consumes around 2/3 of the whole energy. So, I'll proceed further. Love wave do not consume much of the energy. Generally, propagation is along the surface in horizontal direction only. In case of Rayleigh wave, it is the combined effect of P wave, compressional wave, and vertical component of S wave, which interacts with the ground surface and creates Rayleigh waves. In fact, it is a combined action of all these together. At any recording station, we have record of all these types of the wave. The record shows the amplitude of vibrations. It shows the element of time also. And seeing those seismographs, in case we have 2-3 recording stations around any focus, if you know the velocity into time, as we know, gives us the distance. In no time, we are able to locate where exactly this focus is. Here we see the physical action involved in case of love wave. Here, as I told, on the surface only, in horizontal direction, we have the movement. It is not so damaging, but it is the combined effect of P wave, S wave. Out of P wave and S wave, S is more damaging. And out of these two types of surface waves, Rayleigh wave is the most damaging for us because of this elliptical motion, and energy involved is of the order of 2/3. Here in the insert, we see the photograph of Rayleigh, who discovered this type of wave. and just see the elliptical motion of any particle. And here in the picture, we see the Rayleigh waves. Now, the major question is, we are doing a lot of research at micro level, how the soil behaves, how structure behaves. That is all micro level. Major question is whether we know the movement of these major and minor plates. We do not know. We are in the dark. It is something like gray box mechanism. We know something. We do not know most of the things. We are never able to predict. In China, they say that they could predict something. This is the photograph of one record. It shows P waves, velocity is the maximum. It travels through solid, liquid, gases, then S wave, then we have surface waves. Here, amplitude, this amplitude of the wave is less, then it increases. So let us proceed further. Now, let us see about this measurement of magnitude and intensity. Both are quite different. Many of my friends I have seen, they are mixing up the two. Richter scale is being followed all over the world. This is quantitative nature. The values, first column shows the magnitude, 1 to 10. 10 means total disaster. Hardly anybody will survive. So maximum magnitude in the recorded history was in 1960. In Chile, they had an earthquake of magnitude 9.5, which caused disaster there. And in our country also, for example, tsunami 2004, that magnitude was of the order of 9, that caused heavy loss of life, particularly in Nicobar region, Andaman and Nicobar region. I was privileged to be Commissioner cum Secretary and Chief Engineer there. I came across so many cases, so many people died. So magnitude varies from 1 to 10. So as we move from 1 to 2, 2 to 3, this amplitude of the wave gets multiplied by 10 times. If you talk about the energy level, 1 to 2, 2 to 3, this energy level jumps by around 31 times. If you compare one earthquake with magnitude 2 with earthquake of magnitude 3, multiplier is 31. Then if you go to magnitude 4, again multiply with the 31. So if you compare magnitudes of energy released in an earthquake of magnitude 4 with that of 2, multiplier is 1000. Likewise, if you compare energy released in an earthquake of magnitude 6 with that of 2, multiplier will be 10 lakh times. It is like this. Now let us talk about intensity. Intensity, normally we are following this modified Mercalli intensity. Mercalli is named after Italian scientist. Generally, we are following Roman letters 1 to 12. Our Indian standard codes of practice, there also gradation is between 1 to 12. Both these scales are more or less similar. This MMI scale is being followed the world over. It is more popular. Therefore, I am going to that. Here we have intensity of 1, which is hardly perceived by human beings. And when we talk about intensity of 12, it relates to total destruction. And earthquake of this type occur 1 to 3 times in a century. Now, my department, Central PWD, my senior, Dr. S.K. Sharma sir, Dr. S.K. Dhawan sir, he is also a part of that department, our parent department. It has undergone all types of distress due to earthquakes. It is more than 1 century. And for the information of all the participants, I have pride in stating that none of these structures ever faced any noticeable damage, including that in Bhuj. You are aware, 2001, 26th of January, Republic Day, while so many structures suffered damage, thousands and thousands of people were killed. None of the CPWD structures there suffered any damage. Jammu and Kashmir, I was superintending engineer there, later on became chief engineer there. There also, my framed structures did not suffer any loss at all. Even micro level cracking was not visible. Whereas in our structures, Private structures, you forget about that. They are non-engineered construction. We suffered heavy casualty of the order of 2,000 people. People were not following guidelines given by Bureau of Indian Standard Codes. But none of my structures suffered any damage, neither in Kashmir, nor in Andamans, nor in Gujarat, in any part of the country. I have so much of pride in stating that. Because we are following certain practices. We are involved in Bureau of Indian Standard Codes of Practices. I am also one of the code writers. Dr. Dhawan might be contributing. And we are taking information from others also. Our people have been going to Japan, other countries, learning the latest, bringing that knowledge to the country, upgrading our codes. And it is a two-way action. We are learning from them, we are interacting, and we are transferring this information further. As is the case today, whatever little I acquired, I am trying to communicate to you. What are the common types of failures? Dr. Kaltajagi talked about bearing capacity failure of the soil in case shear stresses exceed the bearing capacity of the soil. Then he talked about failure due to excessive settlement, which could be uniform settlement. It could be differential settlement also. A popular example of differential settlement is that in Leaning Tower of Pisa, which is tilting with reference to the vertical by 5 degrees. So that is a major tourist attraction. In fact, it was tilting more. Government of Italy around 25 years back brought it back to a level of 5% inclination so that it maintains that tourist attraction. Professor Jamal Waski was involved as a consultant for bringing it back. And by chance, he was here in Indore, where from I am speaking, to make a presentation on Leaning Tower of Pisa. At some point of time, I had the honor of seeing that Leaning Tower of Pisa also, and I had the occasion to meet that Professor Jamal Waski also, who was here in Indore also, who made a presentation. Now, heaving can take place due to frost action. In Ladakh, we have sub-zero temperature also. Heaving can take place due to expensive soil also. There can be erosion of the soil due to air, due to water also. Then we can have compressible soil, swelling soils, which can cause failure of the nations. Landslides, as we know, it causes lateral displacement of the soil. Volumetric strain can be of the order of 20%, 30%, etc. And it can cause failure of the foundation. Earthquake is the subject matter of discussion today. As we are all aware, it is highly damaging for the foundation also, for the superstructure also. There can be poor construction practices in the shape of improper quality, incorrect choice of the materials, inadequate size of the foundation, not following practices as per laid down practices of design and detailing. And a popular example is the previous month, within a fortnight, as Dr. Dhawan sir also mentioned in the previous presentation, within a fortnight, more than 12 small bridges failed. Now, how come there is another government department here? I'm one of the persons who came out of the department. Dr. Dhawan sir is also a product of the same system, worked at number of levels. How come none of our structures, despite magnitudes of very, very heavy earthquakes of the order of magnitude 9 also, have suffered all this without damage? And how, despite all our knowledge at our command regarding water-induced forces, floods, discharges, forces generated out of that, all that knowledge is available for hundreds of years. How those bridges failed? There lies all the difference. This is what I'm trying to emphasize in today's presentation. Why my structures are not failing, Dr. Dhawan sir's structures included, and why these structures are failing. I'm not making adverse comment on anything specific because the whole process is under investigation. It is proper choice of the materials, proper sizing, proper design and detailing, which we are trying to follow, which saves us. And others, in which cases failure, they are ignoring those aspects, knowingly or unknowingly. Now there is issue, there can be poor water pressure, there can be leakage of underground pipelines also. I remember one case of Palwal in Haryana. I had gone for a course at Roorkee, and we had a technical tour to Palwal also. At a hilltop, there was a house and there was a pipeline of water supply passing below. It leaked heavily, which caused instability of the soil, tilting and damage to the foundation. And in the superstructure, we are surprised to see a particular room in which all the three edges in a corner, X, Y, Z direction, were torn apart to the extent of around 2 feet each, as if somebody has used a knife to cut those edges, sharp edges, up to around 2 feet each. And right in the middle of the slab, we saw ring-like cracks. Leaking of pipe down below can destabilize your foundation, and it can affect your superstructure also. There can be root intrusion into any structural element, which can cause failure of the foundation. There is a British guideline available on this subject, which says that distance of any tree from any structural element should be at least equal to the height of the tree. I don't think anybody in the world is following this type of guideline. Trees we are planting, their roots will definitely grow. When they grow, they will definitely intrude below our foundation and structural elements and will definitely cause distress, including failure. Corrosion, as we know, as soil and water is loaded with chlorides, sulfates, nitrates, phosphates, it can cause failure of foundation made of RCC and steel and any other material, and can cause failure. Now, having listed various types of failure, let us have a look at the picture in the left. This was a photograph taken after an earthquake. Soil appears to be similar. There are three types of the structure, foundation included. One particular structure, all have similar designs, same type of superstructure. This structure stands erect, close proximity. There is another structure which is tilting with reference to the vertical by a certain degree, just like Leaning Tower of Pisa. And third structure, again in close proximity. It has just toppled down. Vertical structure has become horizontal. You see, who is the person on earth who can predict this type of response in close proximity? Whatever our studies are, those are at micro level also. At macro level, earthquake does not require any permission from any one of us. It comes at its own will. It can strike anywhere with whatever magnitude possible. Today I am speaking from Indore, which appears to be very stable place. Tomorrow itself there can be very, very strong earthquake of the magnitude of 9. I do not know. What are the rocks sitting down below, loaded with what level of strain energy? Our guidance of Indian Standard Code of Practice are based on record of previous earthquakes, and we can not be sitting with complacency that I am sitting in zone 2, I am very safe. No, we should do whatever possible relating to ground improvement, relating to proper design and detailing, as we are doing in central PWD, without using any energy saving devices, energy absorption devices. We have not switched over to tuned mass dampers also. Still, my structures have survived history of hundreds of years of earthquakes, because we are following norms. Probably other people unknowingly are ignoring those norms. Now let us have a look at the picture on the right. Here we have a picture. Here Dr. Kalta Jagi, father of the subject, great man who created the subject. We are just following that great man. He talked about three types of the failure, namely general shear failure, local shear failure, and punching. So here in the photograph, this picture belongs to the first category, general shear failure, where we see a general settlement, uniform settlement of the entire structure. This is a typical load settlement curve. This ultimate point of failure is also visible here. We divide it with suitable factor of safety of the order of 2.5 to 3 in case of shallow foundations, with higher levels of safety for deeper foundations, and we arrive at safe bearing capacity. If we consider allowable settlement also, then we arrive at allowable bearing capacity. In case those values are exceeded, then there is likely to be general shear failure, where we have three types of systems here. Then we have zone of radial shear. This is zone of passive resistance. Then we have upheaval of the soil. All these three types of the zones are visible. People have done experiments in MIT. There's a renowned book available. All these three zones are clearly visible in the Grand Book of Lamb and Whitman. They have conducted tests. All these three can be physically seen. Now, in case of local shear failure, this leaning tower of Pisa is cited. That is a case of local shear failure. One side had tilted more with reference to the other side. The general shear failure occurs in case of dense soils with relative density of 70% or higher. When you come to medium types of the soils where relative density is of the order of 30 to 70%, we have local shear failures. Here, this could be the picture like one side has settled more. This is similar to what they had in Leaning Tower of Pisa. One side had tilted, other side had tilted less. And here we see the here we see only two zones, zone of active shear, zone of passive resistance, zone of radial shear, zone of passive resistance is missing. So two types of zones are clearly visible. People have done experiments and physical picture of those types of testing in laboratory are clearly seen in the book by Professor Lamb and Whitman of MIT. That is a famous book. Now, third type of the case, which generally occurs in case of earthquake, that is punching. You have only zone of active shear. And this is a typical load settlement curve where against any applied load at the point of failure, there is sudden rise in settlement with a jerk. And this could be the physical picture like the foundations settles down enormously. It just penetrates into the ground because of this punching. And yet this diagonal cracking like this. In case of you will run to and fro shaking. You will have crack-shaped crack here. This is typical of earthquake loading in case of earthquake. There in Jammu and Kashmir, even in government buildings, I am sorry to say, we saw a number of cross-shaped cracks even in PWD buildings. Seeing their performance, all of us collectively decided to train all J&K engineers in earthquake-resistant construction. IIT Roorkee was there. I was one of the team members along with another colleague of mine, and Bureau of Indian Standard was also involved in the training program, and UNDP also participated. When we talk about relative performance of various types of the foundations, it has been seen in the performance in previous earthquakes that combined footings in general have performed better than shallow foundations because there is some connection between two isolated footings. Raft foundations have performed still better than even combined footings. And in case of rafts, in which beams connect various columns of the foundation system, still better. And region I have indicated because of very good connectivity of all the systems together. And best performance has been seen in the case of deep foundations in general. Here I have shown one slide relating to a deep foundation. Best performance has been observed by piled raft system. Here I shown a slide of a pile foundation system. Even in case of deep foundations, generally we say that these are quite safe. More or less these are performed well. But here also failure can take place. How? You see, there can be liquefaction of some soil layer down below. What is this liquefaction? I will discuss separately in next slides. So, there can be liquefaction. Because of that, there can be excessive bending of the piles. And these piles can have excessive level of bending moments and shear forces. And these piles can fail. Now, coming to this connection between pile top and pile cap, there can be failure at this point due to the application of lateral forces, which are generally predominant in case of earthquake motion. Exceptions have been very few. Kobe earthquake, Japan, their vertical motion became very predominant, and there were failure of many bridges there in Japan in 1995. Here, because of loss of connection between this pile top and pile cap, failure can take place because of this overturning moment. So, even in case of deep foundations, we cannot be complacent. Failure is likely even under these situations. Now, what is of the test for soils? You see, best test at site. For example, prototype testing. When I say that my department, Central PWD, my parent department, that of my respected senior Dr. S.K. Dhawan sir, who is still active, visible here in the screen. Best testing is at site. All these structures done in the country, all these years, history more than have survived all these earthquakes. This is the best test at site. My structures, foundation included, have no reported case of failure of foundation or superstructures. I say with pride and with some extent of authority. I'm not throwing something in the air just like that. It is verifiable. Now, next to that type of prototype testing is micro level testing, which we are doing. So last three tests which I listed here are the field tests, which we normally do. Here the limitation is, best part is that you are doing actually at site. So there is no problem of collecting undisturbed samples, etc. But we have some limitation. You see, high volumetry strains are existing in case of earthquakes. It is just not possible to do high volumetric strain testing in any one of these three tests. You can do testing only at low level of strains of the order of 1%, 2%, or fraction of that 1%. So this is the limitation of this field test. Whereas in earthquakes, particularly strong motion, you have strains of the order of 20, 30%, etc. So to simulate conditions, you have to invariably go in for lab testing. So there it is possible to simulate. You can do simulation studies for 20% strain also, 30% strain also. People have done tests. There are so many research reports available. Let us talk about shear test. Normally we do, particularly for coastal soils. We find out shear parameters C and phi. We have a small size, 6 centimeter by 6 centimeter. Normal load is applied, and then we subject to shearing, find out the normal stress value, shear stress, and then we plot a graph. The line joining those points gives me the value of C. The inclination of that line gives me the angle of internal friction. And then we use the simple equation S equal to C plus sigma tangent phi, which gives me the shear strength. In case of dynamic situation, both C and phi change. In some cases, phi, in case of coastal soil, increases also because of densification. And sometimes phi decreases, particularly in case of clay, etc. So C and phi both are subject to change under dynamic situation. So you have to create oscillations in the laboratory. Setup has to be different. It has to be oscillatory test, and you have to find out dynamic values of C and phi in the laboratory. Now, traxal test we know we are doing in the laboratory. We have small size sample, 3.8 3 centimeter dia, 7.6 centimeter length. Then we are, in case of dynamic situation, we have to subject it to number of cycles. In static condition, we subject to lateral stresses, then we apply deviator stress, and we have values of minor principal stress and major principal stress at this height. Then we draw more circles, and we have 2, 3 tests that got into those more circles. Those give me value of C and phi under static condition. In dynamic conditions, we have to subject the sample to number of cycles. For example, people have done 10 cycles of loading and unloading to simulate earthquake of magnitude 7. Then for 7.5, researchers have used cycles of number 20. To simulate an earthquake of magnitude 8, researchers are subjected to sample to 30 cycles of loading and unloading. So like that, cyclic test has to be done to give us dynamic parameters. And a lot of literature is available to dynamic properties. I'll show some references towards the end. Shake table test, I'll show a slide on that. Actually, you can simulate the situation in the laboratory, and you can subject your sample to shaking and see the physical behavior. SPT test we normally do to do the SPT number, which gives me liquefaction potential also in dynamic condition. As we know, we find out the number of blows required to cause penetration of the order of 1 feet, and we say that higher the value, better is the soil resistance, even in static condition. In dynamic condition also, this dynamic soil resistance that has been correlated with SPT value, corrected N value with correction for pore water, overburden, etc. That has been correlated by researchers for liquefaction potential. For example, in case of N value more than 30, they say liquefaction potential is low. In case value is very low, say of 0.10, liquefaction potential is high. And for values in between, they say it is intermediate potential. Then CPT test, cone penetration test we do for having continuation record of the soil resistance. We are able to find out resistance of the cone in bearing and side friction also we are able to evaluate. Now this cone penetration assembly can be used to find out dynamic resistance also. Under dynamic condition also, this has been useful. And in case of the cone, people have used suitable devices and they have been able to measure body wave velocity propagation also. You know, these wave velocities are related to our Young's modulus, shear modulus, bulk modulus, so many parameters. So this has been used. CPT test has been used for making body wave velocity measurements also. Shear velocity test can be done at the surface also. It can be done in a borehole also. We just strike a plate on the ground, use geophones, receive these signals at number of places, and distance by time, as we know, gives us the velocity. So we get shear velocity at the surface, and we are interested at deeper depth. We can have one borehole, generate shear wave, and receive in the same borehole by using suitable electronic system. We can have number of boreholes also to have more information relating to wider areas. We can have number of boreholes, generate shear wave in some borehole and receive in others. And there are so many variations of this borehole test, uphole test, downhole test, etc. I will cite some references towards the end. Participants who are more interested in deeper learning, they can go through. Now, what are the dynamic soil properties which are required to do simulation studies? We definitely need to know the type of the soil, name and its properties like water content, density, and state of disturbance in initial stage. Then what is the change caused due to dynamic forces? Then what are the number of repetitions of the stress, frequency of loading, shape of waveform, whether we are doing testing in one direction or two direction. You know, all these testing is possible. But again, submit that any amount of accuracy in testing is only at micro level. Macro level is still gray box mechanism. We know very little. Most of the things are still known to us, despite all the knowledge available to us. Now, there is a major question whether magnitude, time, earthquake can be predicted. Answer is no. In China, they say they could predict. You know, there are so many variables involved. What is the timing? What is the magnitude? What is the amplitude of the waveform? Nobody can predict all these parameters, and it varies from place to place. Soil response also we know. Even I have shown one picture where somewhere in earthquake affected area, we saw three types of responses. One structure was vertical, another one was horizontal, third one was inclined, in close proximity. So whatever our studies are, there are limitations. Let us be aware. So what we can do? With whatever accuracy we calculate, we cannot predict forces with confidence. It is only rough assessment. We have to rely more on proper design and detailing, which will help, which is what my department has been doing all along. We can certainly do improvement of the ground. This will help. What we can do, we can stabilize the soil. We know lime and cement we can use. We can do grouting of the soil also. We can densify soil by throwing heavy weights from great heights. Weights of the level of 15, 20 tons can be thrown from great heights like 20 meters, 30 meters using cranes. This will cause cavity in the soil. In case groundwater table is close to the surface, it can cause liquefaction also. It can densify that soil. And it improves the ground characteristics. Those cavities which are caused due to densification, those can be filled up with gravel, and we can compact it suitably. We can go in for dynamic compaction. In fact, for the benefit of all the participants, may I state that there is a dedicated course on ground improvement also by NPTEL. These courses are imparted free of cost. Government of India spends for you. We should be the beneficiaries. I was honored to be named as NPTEL star by NPTEL. I earned 11 courses. Now I am still a student. I am a learner. Now I am a candidate for my 12th certificate. So I have qualified in this course also, run by one professor in IIT Kharagpur. Dynamic compaction, vibro flotation, as you know, this is a well-established technique. We can go into blasting also. We can reinforce the soil suitably by stone columns, geosynthetics, compaction piles. You know, grand books are available on this subject, Indian books also by Dr. Purushottam. Chinese American Dr. Jai Han has written a great book. Indian edition is available, covering most of these techniques, including design examples, available at affordable cost to us. These piles can be in timber, these can be in concrete, these can be in steel, and even in gravel. Of course, you have to compact it properly. That also improves. And drainage, as we know, that improves the ground characteristics, shear characteristics also included. So ground improvement is in your hand. Proper design and detailing is in your hand. Now, beyond that, there are devices, mechanical devices, which can be used. For example, in structures, they have been using TMD system, time, dampers. They are used damping devices to absorb the energy. In Taiwan, they had an earthquake recently. Magnitude was higher than what they had in Japan, and casualty reported is just of the order of 10 only. They have been using the devices. And there is another devices for base isolation. Here, the spelling is not correct. BACE, kindly excuse me. This is BASC. Base isolation. This is already in our country, in Bhuj, during reconstruction. In an hospital, it was used, and thousands of applications are there in our own country. What does it do? It isolates the structure from the substructure. Foundation and structure are separated, isolated by these devices. This is here at the interface of the structure and the foundation. You know, this earthquake ground motion is absorbed. This energy is absorbed by this device, and your structure is saved. All the stories are suffering lateral deformation to the same extent. If you don't use such devices, then this is a second picture. Various stories have undergone drift of various levels. There can be failure of the infill walls, and structural elements can also suffer cracking due to excessive lateral deformation due to earthquake. And magnitude, we do not know. Time, we do not know. Soil resistance, we do not know. Whatever studies we have, those are at micro level only. Macro level is beyond our control. That is at the mercy of the Almighty. What is the Indian Standard Code of Practice? That is in our hands. We should follow the norms. 1893 is the code of practice which gives us the criteria for earthquake-resistant design. There are other codes also relating to earthquake, design and detailing for non-engineered construction also. All these codes are available free of cost. Free downloads are available. Part 1 deals with buildings, Part 2 deals with water tanks, Part 3 deals with bridges, retaining walls, Part 4 deals with other structures. Now, this code considers the whole country divided into 4 zones. Earlier, we were having 5 zones. Zone 1, 2, 3, 4, 5. But what happened? Latur, in Kilari in 1993, we had a strong earthquake. So we lost faith in that zone 1. So now that zone 1 must be zone 2. We don't have any zone 1 now. So zone 2 is the smallest zone now. And horizontal acceleration is to be multiplied by a seismic coefficient expression for which is given in our code to work out the acceleration in the horizontal direction. And likewise, we can work out acceleration in the vertical direction also. If you know the acceleration, we know the Newton's law, mass into acceleration gives me the force. And if you know the distance of our CG from that force, we can calculate the overturning moments also. This is very simple logic which we can do. Now this is the seismic map. Now zone 1 is not there. Safest zone is zone 2. I am sitting here at zone which is at the boundary of zone 2 and 3. We think that this is the most stable. But tomorrow there can be strong earthquake here itself. Here we had a strong earthquake in 1936 and later on also. Chennai is in zone 3, relatively more stable as compared to zone 5, shown in the deep red color. There also in 1925, there was a strong earthquake and later on also. And there were damage due to tsunami waves also. And there was very heavy flooding some years back where one story of houses in coastal region were just drowned. All these forces, and we do not know how to look after. Most of these things are still unknown. So zone 5, Andaman and Nicobar is in zone 5. I happen to be Commissioner, Secretary and Chief Engineer there. That is the most vulnerable. In North Andaman, Diglipur, we have earthquake shaking every day. Of course, magnitude is very low, so that is not being reported. The Northeast is zone 5, is Himalayan range, areas of Gujarat near Kutch. All these are most vulnerable based on previous records. Mind you, earthquake does not require any permission from me, neither from this seismic map. It will come at its own strong will. Our map follows the history of earthquakes, not the other way around. So we have to be prepared for the worst. Somebody has said, hope for the best, be prepared for the worst, and you have to accept whatever comes. And zone 4 also, this is based on previous history. This does not offer us any guarantee of any kind. Now the code gives seismic zone factors for zone 2, 3, 4, 5, various values are given. Generally, value gets multiplied by around 1.5 times as you move to higher zones. Then for various types of the soil, if you are considering earthquake loading also, other than the normal loads of dead loads and live loads, etc., the code permits increase in net bearing pressure and skin friction up to 50% in case of rock or hard soils, which are the best types of the soils, up to 50%. When you are considering all these forces, apart from the normal forces of dead load, live load, etc. Then medium of stiff soils for those types of the soils. And this classification is based on our N value, which I just shown briefly. This percentage increase is allowed up to 25%. For soft soils, which are the most vulnerable, these can amplify the wave amplitude and cause heavy damage. No such increase is allowed for obvious reasons. Now, the code gives acceleration values against natural time period for 3 types of the soil. Obviously, against any natural time period, value the minimum for hard soil, maximum for soft soil as expected. For medium soil, it is in between. There are 2 types of the graphs, and these are against consideration of 5% of damping. Normally, this damping value varies from 1 to 10. And for values other than this 5%, correction factors are available in the code. And maximum value given is 2.5. Both these types of curve, one is for equivalent static curve, where we are converting dynamic loading into equivalent static forces. Second one is dynamic loading based on spring mass system, etc. And curves are similar. There is minor difference when time period is less than 1 second. Otherwise, values are similar. You can follow any one of these techniques as per this code. The code gives an expression for design horizontal seismic coefficient. Here we have Z by 2, SA by G, I by R. Z is the zone factor given in the table. Now, what is this 2? Our philosophy of design is that under minor shaking, we should have minor cracking, etc., which can be easily repaired. Against moderate level of shaking, you should be able to repair and rehabilitate. And against very strong shaking, there should not be any collapse. So we are never designing our structures for maximum credible value. Our philosophy, as per code itself, is for design basis is for 50% of the maximum credible value. That is why this value 2 is coming. Of course, in case of other structures like atomic structure, etc., we cannot take any risk There we don't have to go by this provision. You have to, in fact, apply suitable factor of safety. If there is a failure in that type of structure, there will be catastrophic damage, not only to the structure, to the human life also. So there things are different. For most of the other structures, including structures being done by my department, we are following this practice. SFIG, we have to see from that graph, I is the important factor. For ordinary building, it is 1. For structures with occupation of more than 200 people, this value is specified as 1.2. For important structures like hospital, etc., value is given as 1.5. R is the response reduction factor. Normally, this value varies from 1 to 10, and this is specified. The code says, when not specified, it shall be taken as corresponding to 5%, which is generally considered as the average value. Otherwise, these values vary from 1 to 10. And Codal guidelines are available regarding this damping. Now, in the vertical direction, our thinking is that acceleration in the vertical direction of is 2/3 of what we have in the horizontal direction. Earlier, this value was 1/2. But there were so many experiences, particularly in Kobe in Japan, 1995. Everywhere, all over the world, this value was upgraded to 2/3. So our thinking is that there can be acceleration due to earthquake to the level of 2/3 of what we are in the horizontal direction. That is how this 2/3 has come in our course. And for buildings and water tanks, this maximum value of 2.5 against consideration of 5% damping has come. And for other structures, you have to refer to the graph. The code gives an expression for time period also, which is required for finding out that SA/G value, which I had shown in a graph. It is related to the height of the structure, lateral dimensions, and area of the walls also. Against this time period, you have to have a look at that graph and see your SA/G value and use in those coefficients, and then you have to find out acceleration in horizontal and vertical direction. Now, what is the basic analysis? For an earthquake-resistant design, spread footings of columns must be interconnected. Now, this first sentence is the most important. Collectively, united we stand, divided we fall. Same philosophy applies to our superstructure. Wherever we connect properly by providing bands, corner reinforcement, etc., structure stands. That is what we do in CPWD. And divided we fall. Provide connection at right angles. This earthquake waves come at random. Magnitude is not known. We are not certain about the magnitude, and we are not certain about soil resistance also. Whatever studies we do, those are at micro level. Macro level is still a gray area. The bending moments and shear forces in beams may be computed like this. Determine the moment at the foot of each column, assuming that the column is fixed. Assuming that the footing has no resistance to rotation, distribute the column moments found above in proportion to the stiffness of the foundation beams and columns joined at each footing. In fact, similar philosophy we are following for superstructure also. When we do moment distribution, we divide any unbalanced moment in the ratio of stiffness of various beams and columns, etc., which are joining. Kani's method, etc., are based on the same philosophy. The great beams connect various columns from the foundation system. Minimum reinforcement should be 0.8%, and it could be higher depending on assessment of our forces. And you have to provide stirrups properly with end hooks, and hook length should be minimum 10D as specified in the codes. And these have to be turned at 135 degrees. Experience has shown that wherever such types of beams have been provided, such beams have survived. The beams with less end length and just turned at 90 degrees, which is the common practice, I am sorry to stay in most of the private buildings and in government buildings also, because of lack of knowledge or because of our ignorance. Those types of beams can fail. In my department, perfection is not possible, but we are trying to follow this. And spacing of stirrups could be, dia could be 6 mm, 8 mm. Spacing can be minimum near the edges as per our calculation, up to 3 inches. It could rise to around 9 inches toward the center. We have to calculate properly, and emphasis should be on proper design and detailing. No, this is available to compute effect of differential force of putting on superstructures. At research stage, we have some papers on that. Great beams recommended are believed to increase the rigidity of the entire foundation. This, I will say, is the most important. This connectivity helps. Refinement in analysis has limited importance. This may help reduce the differential distortion between the individual footings. Now, for piles, let us have a look. Very little has been provided in building design codes, and permissible increase I have shown in a table, and total loads on the piles are worked out from consideration of vertical load, frame moment, and local moment. I am citing my great professor Prakash ji, Sanjay Prakash, great man. I had honor of working with him at Roorkee before joining Central PWD. Then there is some Sharma, not me, he is some senior Sharma. And he is the first professor of soil dynamics in the country, had done great work in the country. His student, Professor Swami Sharan, great work, great books. I'll cite towards the end. They have done great work in our country in soil dynamics and dynamic resistance of piles, etc. Now, there are many methods of handling the problem of dynamic bearing capacity, but let me cite that these have limited value because macro level is not in our hand. Pseudostatic method where we convert dynamic forces into equivalent static forces based on single degree freedom, spring mass system, spring stiffness is related to soil characteristic. For example, K could be equal to Cu into A. Cu is coefficient of uniform compression, which we can find out by conducting tests. They will use 2D freedom, 3D freedom also, but complexity of analysis increases and it has limited value to us. Method based on wave propagation, wave characteristics are related to our Young's modulus, shear modulus, Poisson's ratio, etc. Method based on equilibrium of failure wedge. Here you have to consider dynamic loading also, non-dimensional analysis, numerical technique. I'll cite some references towards the end, which give information relating to all these techniques. Now, let me discuss another important situation, liquefaction. I'm hurrying up. I'm aware about the time constraints. I'll quickly try to conclude. Liquefaction occurs only when there is proximity to water. In case water table is very deep, there cannot be any liquefaction. We had liquefaction in Gujarat, Bhuj, 2000, Republic Day, because there was water close by. And it happens in case of silts, it happens in case of fine sands. In Gujarat, we had loose alluvial soil near riverbed. Our structures suffered. Our people also suffered. Heavy loss of human life and heavy loss of structures also. And generally, it does not occur in rocks. It does not occur in most of the clays. Exception is sensitive clays and marine clay. Silt and fine sand. Yes, it occurs. Shear strength, as you know, is given as S equal to C plus sigma tangent phi, famous Moore-Coulomb equation. Here, if you are talking about saturated sand or partially saturated sand, it is cohesionless. So C does not come in picture. Cohesion value is taken as 0. Again, normal stress, we have effective stress. Here, pore water pressure comes in picture, which we can calculate easily. Pore water pressure is given by gamma W into Z, unit weight of water into depth. And in case pore water pressure rises high, and suppose it equals in normal stress, your shear strength may come down, it may vanish, and failure can take place. Let us see whether we can see this slide. In shake table, we can do simulation. What we can do, we can have a spring-mounted system. We can have a tray. We can have the soil available at site, subject the sample of the soil there to testing. We can have a model of the superstructure and the foundation and subject it to the forces. And we can see the reaction, how the soil behaves. And just see, this is the model of my structure and foundation. We call it quicksand also. We call it liquefact. Just see, soil boils we can see, sand boils we call it. Actually on the ground, in liquefaction affected area, we can see sand boils around. And just see what happens. This is exactly what happens in case of liquefaction. So if we can improve the ground, it can help. And we'll see further picture on that to enlighten us further. As such, this structure is safe and sound. but due to application of the dynamic forces, pore water comes in picture. And if we consider one element of soil like this, it is subjected to normal major and minor principal stresses. This is the Mohr circle. Failure and will we are safe as long as it is away. Now, due to this pore water pressure coming into picture, we have another more circle corresponding to effective stresses. As it touches the failure envelope, as per our theory, soil collapse will take place. This is exactly what happens in case of liquefaction. Now, let us have a closer look at this Japan earthquake. Magnitude of this earthquake was, are you able to see the slides? Somebody may confirm, sir. Is it visible, sir?
No.
Okay. Slide is not visible, sir.
Not visible.
Now?
No.
Now, sir?
No.
Even not? Okay, sir. Are you able to see now, sir?
No, just say without slide. Just,
Not visible?
no.
You see, even in Japan, most of the structures survived, except load-bearing structure, because they are using damping devices, etc. But there also they face casualty to the tune of 160 persons. Here in our earthquake, magnitude of forces was what happened in Kashmir? Lateral forces was just to the tune of 3% what they had in Japan. Our casualty was 2,000, Uri, Tangdhar and Kamalkot. Because our people were doing stone masonry in mud mortar without following proper norms, etc. That is why we face problems. So we trained all those people. I constructed model huts, model construction in Uri and Tangdhar region, in brick masonry, stone masonry. We had training programs along with IIT Roorkee. We trained all those engineers in earthquake-resistant construction. Those practices were followed. All those engineers trained by us were sent to various villages, 95 numbers. They certified that reconstruction has been done as per our norms. Then only government released assistance. I ensured this practice right up to line of control. So let us conclude. Earthquake loading is highly probabilistic. It is not deterministic at all. Japan faces 6 to 7 earthquakes of various magnitudes every day. We also face in the middle Andaman near Mayabandar, we have volcanic activity. One particular island, a barren island, has lava eruption every day. No habitation is possible. Earthquake cannot be avoided, nor can be predicted. So we have to focus more on proper design and detailing and ground improvement. That is exactly what we are doing in Central PWD. We don't have any magic. We are simply trying to follow the norms. And my structures, Dr. Dhawan's structures included, have survived all these years, hundreds of years. We have a history of more than 150 years. That is the best possible test at site. Steps for proper analysis and design of foundation and the structures have to be undertaken as per Codal guidelines and good engineering practices. So here I quote the books which are followed by Professor Maheshwari of IIT Roorkee also, who conducted the course on this earthquake-resistant design of foundation, by my great Professor Shamsher Prakash, with whom I had the honor of working for some time before joining Central PWD. This is a great international book. Download is easily available. Kramer's great book on earthquake-resistant engineering. Download is easily available. Bau's great book. Most of the material is in static conditions, but he has given some content relating to dynamic parameters also, and lot of data is available. Indian edition is easily available. And great book by Professor at Roorkee, Professor Gopal Ranjan, A.S. Ramchandra Rao. Great book. And there is yet another book by Professor V.N.S. Murthy, Advanced Geotechnical Engineering, another grand book. Professor Swami Sharan, student of Professor Prakash, he has upgraded the book in 1981 in this book of 2006, and he has come out with yet another book in 2019. Easily available, marketed by Wiley International. So all this book gives most of the information which I have given in this short time span of 1 hour. I am thankful to all the participants. There were constraints of time. I have tried to consolidate the information in all those books I have cited. I have personally gone through each and every word, including Professor Swami Sharan's latest book, 2019. I have gone through all those 40 lectures of Professor Maheshwari. I am still a learner, going through yet another course on geotechnical earthquake engineering, and registration is still open for the next 3-4 days. 2 courses are running, one by Professor Maheshwari himself, another one by IIT Kharagpur. It is free of cost. Registration is free of cost. Only for getting a certificate, you have to write the exam. There a minor fees of 1,000 rupees only. I advocate, because this is my own country is spending a lot of money so that people like you are benefited. Avail of these courses. I am already an NPTEL star. Tomorrow you can be an NPTEL star. They honored me. They came physically. You can also be honored tomorrow. This is what I wanted to say. If there are any questions, I will be happy to answer. Difficult questions can be answered by our enlightened Dr. S.K. Dhawan. If there are simple questions, it is within my capacity to answer. Thanks, sir.
Dr. Sharma, excellent presentation. Now, participants, if you have any questions, Vikas, please just read and then Professor Sharma will just answer those questions.
Yes, sir, there are a few questions.
Please continue.
Mr. Vikas, will you speak a bit loudly?
Okay, sir. Okay, sir. Yeah, so there are a few questions. First question is from Mr. Rahish Ahmed Bhatt. He asks, if water table is below 1 meter from NSL, we need basement going 3.5 meter depth from NSL. Water is not controlled, aquifer is developed. Raft foundation recommended. Will waterproofing is okay? Foundation of slopes.
Yes, sir. If you talk comparatively, raft foundations are definitely better. But since water table is near the ground surface, and in case of fine sands, silt, etc., it has high liquefaction potential. So that aspect should be seen. N value you should see. In case N value is very, very low, less than 10 or so, soil is likely to liquefy. There are not many studies available relating to liquefaction. I will suggest kindly go through that material. But in case of fine sand, silt, liquefaction is likely, particularly in case of loose soils where N value is of very low order, less than 10, 5 or so. In case N value is very high, then of course we can sit with complacency. In general, raft foundations have performed well as seen in performance during previous earthquakes. Thank you.
Yes, so the next question is, how do different soil types influence the seismic resistance of buildings during an earthquake?
Yes, generally dense soils, well compacted soils, generally rocky strata, this type of formation generally behave well. Loose soil with relative density, we know E max minus E divided by E max minus E minimum. If it is less than 20, 10%, then those are suspect types of the soils. So we should definitely look after, if we can change our site, nothing like that. If you cannot change the site, already decided, then definitely ground improvement techniques are available. Soil stabilization, improving, we can go in for densification, we can improve C, we can improve phi, we can improve other parameters. And there is a full-fledged course on ground improvement also conducted one by Professor of IIT Roorkee. IIT Kharagpur. Grand course. I undergone that course. And grand book by Dr. Jai Han, Chinese American. I am not a big fan of China or America, but that book is grand. Indian edition is available. And Dr. Purushottam has written an Indian book also. But the Jai Han's book gives practical examples also, which can be helpful to the field engineer. Thank you.
Yes, sir. Mr. P.V. Narayan Rao asked, will rainwater harvesting pits within battery limit of building impacts foundation stability?
Normally we are having pits of very small size, and normally we have very shallow depth only. Only what we do, we dig a pit, then we take that rainwater down below through holes, etc. So generally, we have not come across any studies so far where rainwater harvesting system has affected our foundational structures. In future, we do not know, but so far, as per the present understanding, we have not come across any damage caused anywhere. Thank you.
Yes, sir. Mr. S. Krishnan asked, when and why do vertical excitations dominate as compared to the usually dominant horizontal component of ground shaking?
Sir, very good question. Normally, it is predominant. These plates, these are not all horizontal. These have oblique orientations. When these plates will strike and in which direction this random motion will take place, we do not know. Nobody knows. And in fact, it is a surface wave which affects more, particularly in the vertical direction, Rayleigh wave. That is the outcome of striking of this P wave and vertical component of S wave. When these interact with the surface, we have Rayleigh wave. These particles have elliptical motion, which is very, very damaging. So generally, in most of the cases, as I seen after going through all these texts, it is generally the horizontal value which is predominant. Now, people are sitting with complacency that nothing happens in the vertical direction. Most of our, in fact, in most vertical direction, most of these structures have been designed very well. Normally, most of the structures are being looked after. When we design, we calculate, we have a multiplier for dead load and live load also. Then we consider wind forces or earthquake forces also, even in case of superstructures. So in general, in vertical directions, most of these structures are able to bear. It is only the horizontal direction of which we are totally ignorant. In my department also, very less had been done, but it is by God's grace that because of proper construction practices, etc., my department, including Dr. Dhawan's department, Central PWD, these structures have survived so far by God's grace. Otherwise, anything could have happened. We are totally ignorant, generally ignorant about resistance in the horizontal direction. So in Japan, they were just sitting complacent that it happens in horizontal direction. And something struck in vertical direction in Kobe, 1995. After that, it created awareness. This 1/2 value was upgraded to 2/3. That is the outcome of that only, as far as my knowledge goes. Yes, sir.
Yes, sir. The next question, Mr. Anvesh Bhaduri asked, in cases of foundations on slopes, when lateral confinement is not available, which is a better foundation in this case, a raft with retaining walls or deep foundation?
Deep foundations in general have behaved very well, not only in our country, everywhere in the world. Best foundation is by raft, piled raft system. Good books are available. And for your kind information, again, it is my department. One of our seniors, S.C. Gupta sir, he has come out with a book on raft piled foundations also. That work was done in Central Designs Organization when I happened to be working under that S.C. Gupta ji. Not my contribution. That was by another colleague, Roy Chaudhary. He did most of the work. That piled raft foundation has performed the best. Raft foundation has also survived, particularly in case of raft with beams connecting various columns of the foundation system. Problem comes in case of retaining walls. In Andaman and Nicobar Islands, in a particular island, somebody constructed a retaining wall. It slided by around 10 feet without any cracking on that retaining wall and seated very well at a distance of 10 feet because of this lateral spreading. Now, these are the things we have to look after. Heavy volumetric strains and resistance against these forces. We must provide suitable key, etc. below the base. We should have suitable anchor system also for the retaining walls. Otherwise, in vulnerable areas, anything can happen. I saw one case in Andaman Nicobar Islands. Structure was intact. Because of the lateral forces, it slided by 10 feet and was seated at another location without any cracking. That was a great situation. Yes, sir.
Yes, sir. Mr. Amit Nikam asks, what are the changes in seismic calculations in liquefied soil?
For liquefaction guidelines are available. When people are drawing these guidelines, my officers of the department are always a part. Central PWD has been contributing 100% in all the codes relating to civil engineering. I am also contributing. I am a member of CSD5, and we are open to anybody in the country can contribute. So our presence is there in all the design codes relating to earthquakes also. And we have people well trained in that. And professors of earthquake engineering department, IIT Roorkee are there. They have very good interaction with field problems also. So I presume that most of the guidelines available anywhere in the world are creeping into our codes of practice. If we follow our practices, I think that is sufficient guarantee. But the whole thing is probabilistic. Thank you.
Yes, sir. There is a question from Vaikalpik Engineering. Someone has wrote, in the notes below table for types of soil in IS 1893 P1, it is mentioned to adopt ground improvement if N value is less than 10 and 15. Is this mandatory or to be done only if one want to consider increased SBC in calculations?
You see, this N value, Dr. Tarjagi's work is based on these N value parameters. In static conditions, we had been using this value. Even when we are measuring dynamic resistance, it is seen that it is the same N value which is coming in research papers. This is a great test. If the code gives these guidelines, my comment is that invariably we should follow these guidelines, because at macro level, nobody knows. We are not certain about, as I'm repeatedly telling, about the magnitude of the forces, direction of the forces, and we are not certain about soil resistance also. So we are sitting on a volcano. So whatever is available, at least that should be followed, not by one, by all.
Yes, sir. Mr. Arshad Ahmed asks, what would you suggest for infrastructures like dams and roads, rail, etc.?
In case of dams, etc., first thing is selection of the site. It is not that we choose the site first and then we construct dams. By chance, I had the honor of working for Dhani Dam in Andaman also. I was part of that construction work. Normally, we are siting such dams in relatively safe areas. We have a lot of choices. It is not necessary for us to construct dams only at a particular location. Lot of soil exploration is done. Then view of the hydrogeologist is also taken. And after lots of thinking, research work, then only site is selected. So a lot of brain work goes in that itself. If despite that problem comes, then solutions are available. But we cannot afford to have failure of structures like dam. Just like atomic reactors, we cannot afford to have failure. We cannot afford to have failure of any dam. If that happens, there will be loss of human life, great loss, apart from heavy expenditures involved in dams.
Yes, sir.
Yes, sir.
Yes, sir. Mr. Salman asks, one site basement excavation done, but such restriction on site, so excavation again filled by this soil. So how it possible footing rest over this disturbed soil?
Over disturbed soil, definitely we should be careful. Soil exploration, we should not ignore. But unfortunately, let me tell you what is happening. There are very, very few people in the country who are sincere about this soil testing. Lot of cooking up exercise goes on, as I'm witnessing at number of sites. People just see one result, copy and paste, submit. Such trends are dangerous, particularly when we are dealing with dynamic forces. Let me admit, malpractices, in a particular state, Dr. Dhawan also commented in the previous presentation of Madam, lot many things are happening. We cannot afford to have manipulations in soil test report. We should be honest to that. If in case of disturbed soil, just seek experts' advice. Just do whatever possible as per expert advice. We cannot ignore. We cannot afford to ignore. Because in case your foundation fails, nobody can save us. Beam can fail, we can do something. If column fails, it is more damaging. If foundation fails, we are nowhere. And if soil also fails, gone. So we have to be extra careful.
Yes, sir. This is the last question.
Yes.
Could you highlight use of cantilever isolated footing on boundary line?
Cantilevers are the most dangerous structural systems. If we have a choice, cantilever in superstructure as well as foundations, that should be minimized. Because just going by gross values, in case of any cantilever, bending moment WL square by 2, all of us know. If you talk about any structural element, we go by WL square by 12, WL square by 10, simply supported WL square by 8, like that. In case of cantilever, bending moments are the maximum. So in dynamic situations, cantilever structural system is the first to fail. In Jammu and Kashmir also, where I was involved in going into defective construction, suggest to the government what should be done. Cantilevers in non-engineered construction failed everywhere. So we should avoid. If we cannot avoid, we should minimize. If you cannot avoid that, just do whatever possible. Because somebody has said, whatever has to happen will happen. But we cannot afford to have failure of foundation. We should be extra cautious. Thank you, sir.
Yes, sir. Two questions are also come. First one is Mr. SVG Krishna Rao. Please suggest handbook on stone columns for strengthening.
I'm very happy. I'm great lover of books. I don't like anything like Chinese. Jai Han, Jaihan. Great book on ground improvement. Indian edition is available for a cost slightly more than 1,000 rupees. Dr. Purushottam's book is also available, but design data is relatively less. And that Dr. Satyendra Mittal, he has been working, IIT Roorkee, he is working on stone columns. He has written books also. But if you talk about a book in general, Jai Han is probably #1 book. International available, Indian edition is available. I have gone through that book. It has given great examples, including practical examples. Any other questions, sir?
Yes, sir. Mr. Rohit Kumar, this is the last question. Mr.
Yes.
Rohit Kumar asked, what are the best method economical for increasing the soil bearing capacity in India? Where the coast region we have 12T/M2, how to increase the bearing capacity? How far geogrid method of soil stabilization is good for increasing bearing capacity?
Right. You see, bearing capacity as per father of the subject, Dr. Karl Tarjagi, he talks about C and phi values. He has given bearing capacity factor NC and gamma, which are related to phi values. So C and phi are important factors. which give us bearing capacity, gross bearing capacity, as all of you must be knowing, C and C plus gamma D and Q plus half gamma B and gamma for strip footing. So C and phi are important parameters for bearing capacity. So densification of the soil, as density in C and phi both change when you improve the ground. So improvement of C, improvement in the value of phi. Of course, in case of C, you can have other adverse results also. There is certain value of cohesion available and it can be disturbed. Phi definitely improves if you go in for densification. Number of techniques I had listed, and these are not the only techniques. And this grouting, etc. also, that can also be used for improving the bearing capacity. Thank you.
Thank you, Professor Dr. Sharma, for sparing your valuable time and sharing your long experience in the field. The message to young engineers: do the right job at the first time, proper investigation, proper design, detailing, good construction practice, follow codes, then drainage, ground improvement, and other things which are really required have to be examined, and then to take care. Structure should last for 100 years, and then collapse of structure, see, that shows that our profession will get a bad name. Again, I am on behalf of Association of Structural Engineers, I thank Dr. Sharma to spare his valuable time and share his long experience in the field of civil engineering. Now, the next lecture would be on 22nd of August on a different topic. So, gentlemen, avail this opportunity, try to listen and learn something and use that practice in your field as and when is required. So, thank you once again. And then we conclude.
Sir, there is a request. These responses of people in chat box, people have written, can this be passed on my mail by Vikas? In chat box, people have given some reactions.
Yes, sir. Yes, sir. I can mail you.
Including thanks and all.
Yes, sir. I will mail you.
But excellent presentation, I would say.
Thank you, sir. I am grateful to my grandson. I am Kaushik, who helped me in preparing these slides. Then I am thankful to my daughter, Shweta Kaushik, teaching in Hyderabad, civil engineering. They helped me in preparation of this presentation. Thank you, sir.
Right.